Hello everyone. So the topic for today's session is performance testing in Kafka and managing test data. My name is Renu Singh and I am from Business Analyst Competency. I will be presenting you this topic. So let's begin with it. And before beginning with it, let's go through NashKnolX etiquettes. So basically, we have four NashKnolX etiquettes. One is punctuality. Join the session 5 minutes prior to the session start time. We start on time and conclude on time. And the second is feedback. Make sure to submit a constructive feedback for all sessions as it is very helpful for the presenter. Second is a silent mode. Keep your mobile devices in silent mode and feel free to move out of the session in case you need to attend an urgent call. And the last one is avoid disturbance. Avoid unwanted chit chat during the session. Now, let's go through the agenda of today's topic. So, I will be walking you through introduction to Kafka and what is Apache Kafka, working of Kafka, advantages of Kafka, Kafka core APIs, and another one will be load testing Kafka with JMeter. So in this, I will be explaining like what is JMeter and Apache JMeter working and why JMeter we choose JMeter for Kafka load testing. Then in the next section, we will be discussing key metrics for load testing. In this, we will be particularly discussing the key metrics related to Kafka. And then we will be discussing about setting up Kafka. So setting up Kafka is a little tricky. So I will be walking you through that, do that. And after that, we will be going through the demo. So let's begin with introduction to Kafka. So what is Apache Kafka? So Apache Kafka is open source distributed streaming platform built for high throughput, fault tolerance, and scalability. It handles real-time data pipelines and stream processing at scale. Combined feature of messaging and storage. User can publish and subscribe, which is it can produce or consume and store, process streams of records all in real time. Apache Kafka is like a post office for data. Producer are like who write letters, that is data, and drop them into the post office. And the post office, which is Kafka, organizes these letters into mailboxes called topics. Consumers are like people who open the mailbox and read the letters whenever they want. So this image basically illustrate the basic data flow in Apache Kafka between producer, topics, and consumer. So on the left-hand side, we can see the producer. These are the application or services that create messages or records. The arrow shows the producer send the data into Kafka, and Kafka cluster, which is the middle symbol, it basically circle and connect the dot represents the Kafka broker or cluster, which act as a backbone for handling the data flow. So what happens here is when producer sends their record into Kafka, Kafka stores them into topics, and topic which is represented in the center of the box. Uh, a topic is basically a logical channel in Kafka where records are published. Think of it like a category or feed name. Like for example, we have a user activity topic might store logs or logs of user interaction. Inside a topic, data is stored in an ordered, appended only sequence. And consumers on the right side, these are the application or services that read or consume data from Kafka topics. Multiple consumer can subscribe to the same topic, each getting a copy of the records depending upon the consumer group configuration. So this is what is Apache Kafka is all about. Now we will be looking into working of Kafka. So working of Kafka, Kafka is basically like a big message hub where application talk to each other using messages. And in Kafka, as discussed before, we have producer topics and partition or brokers, which are basically in the Kafka, and consumers. So producers send messages into Kafka like an order being placed, and topics are like categories or channel where messages are stored. Like for example, you can create a topic name orders, and whenever a new order is placed, it is gets stored directly into the topic called orders. Then each topic can be split and partitioned into parallelism for scalability. So that's where the partitions came in picture. And brokers, what brokers do is brokers are basically Kafka servers that stores and serve these messages to consumers. So consumers read all these messages from topic like an inventory system reading order to update stock. Here in this in example, we have e-commerce website where multiple things are happening at a time, like someone is either making a payment, or on the back end inventory is getting updated, or an order is getting placed, or user are just accessing the e-commerce website. So when all this happens in the background, what Kafka does is it just send the messages to the consumers, and everything is happens smoothly at the back end of the application. Next, what is the advantages of Kafka? So the advantages of using Kafka as a messaging system are listed here. So what happens in Kafka is it supports low latency message delivery, and it guarantees that the fault tolerance with zero data loss. Kafka is persist all data to the disk, and all the writes go to the pages cache of the RAM memory. It can handle many diverse customers. Like at a time, there can be hundreds of customers sending messages to Kafka, and it will be partitioning it into different topics, or even in the same topic, and will be producing the messages which will be received by the consumer at the end. And it is very fast, and it can perform basically 2 million writes per second. It has high throughput for publishing and subscribing messages. Even if many TB of messages are stored, and it maintains its stable performance. So we can see that in Kafka we are sending like a huge amount of data in forms of messages, and we are consuming it at the consumer level. So due to this reason, we need to like load test this Kafka and see the performance of like how it is performing. Is it actually performing the very well or not? So to check these, we have the four core APIs of the Kafka, where basically the whole Kafka functions. So here is a diagram illustrating the four core APIs: producer API, consumer API, and then we have streams API and connector APIs. So what producer API do is it allows an application to publish a stream of records to one or more Kafka topics, and the producer is responsible for assigning the records to a specific partition within the topic. And what consumer API do is it allows an application to subscribe to one or more topics and process the stream of records produced to them. And stream APIs do is it allows application to act as a stream processor, consuming an input stream from one or more topics and producing an output stream to one or more output topics, effectively transforming the input stream to output stream. Then we have connector APIs. So what connector API do, it allows to build and run reusable producer and consumer that connects Kafka topic to existing application or data system. So here we have covered all of the four APIs, and as you can see that in the diagram, the producer application is sending the messages, and at the end, consumers are receiving, and the connectors are basically acting as a DB, and the stream processors are the apps, as told that they allow the applications to act as a stream processor for consuming input stream from one or more topics and producing an output stream. So it happens both of the ways. Moving next, load testing Kafka with JMeter.
Yeah, Renu, I have a question. Can you hear me?
Yes, I can hear you.
So, can you move back into your previous slide? So, you are saying
Yeah.
stream processor. So, stream processor is a separate entity in Kafka, or is it or is it a consumer that is reading on a particular topic? It has to be a separate entity on one side. Can you explain me a
Yes,
little
I
bit?
think it is a separate entity. Like we have Stream API, which basically allows to the processes to happen. Like allows the producer and the consumer to communicate with each other. So that's what it is used for.
So this is basically message streaming, right? Like the producers are producing messages on topic, and we are having a stream, Kafka stream API running on top of it as consumers, or something
Uh,
else.
yeah, something like that. Just you said.
So they're just consumers where we are using Kafka streams for reading the messages and doing our operations, right?
Yeah, I think you're right, but I'm not sure about it. So I will come back to your question, like by
No,
confirming it
no
once
issues.
I'm done.
Yeah, thank you.
Thank you. The next is load testing Kafka with JMeter. So, what is JMeter? So, Apache JMeter is an open source software application which is purely based on Java and used for testing like load testing, functional behavior, or measuring performance. It is used for testing a variety of services like web application, databases, etc. So the features of JMeters are very powerful. Like it can do performance testing, load testing, functional testing, protocol support, scripting, distributed testing, and graphical reporting. So distributed testing can be done via uh, making changes to the script, and the graphical reporting we can add plugins like we can use Grafana, and for scripting purpose we have Groovy or Bean Shell, where we can do scripting to manipulate our scripts and make changes as per our requirement. And we can do load testing by simulating thread user as per the requirement. Like we can add 100 of thread users which will be act as virtual users, and will be increasing the load on the particular application under test. And for functional testing we can test like each and every API that is being called, it is functioning in the right way or not. So these all things which we can perform via JMeter. And now we will be talking about working of Apache JMeter. So since JMeter is a Java-based application, so it simulates a group of users and send requests to the target server, and returns the statistic like throughput time or the error rates, and it shows the functionality and performance of the server. Here in this diagram, you can see that we have user requests for server connection. So these requests are sent via JMeter to the server, and what the server does is it server when we hit the server, it gives us a response, and what JMeter does, it saves the response, and after saving the response, we can basically manipulate the data. Like what happens when we record any script on JMeter. Sometimes the scripts or API calls are dynamic, and to um, simulate real scenarios, we need to make these dynamic elements into variables, and we then manipulate the script as per our requirement, and then we when this is done, what end process happens, we on running the script, we can generate a report or get a summary of all the APIs being passed, or the status code, or the time it is taking to giving us a response. So these are all the things that we can do with JMeter. Next, why we use JMeter for Kafka load testing. So Kafka already comes with its own testing tools like Kafka Producer Perf Test and Kafka Consumer Perf Test. These tools are great when you just want to measure basic things like how fast messages can be produced or consumed in isolation. But in the real world, workloads are rarely that simple. You will have different payloads, sizes, multiple topics, consumer groups, or more. And that's where Kafka native tool falls short. they can't easily simulate those complex scenarios. And that's where JMeter comes into picture. And JMeter basically brings flexibility. This with Kafka plugin in JMeter, we have an plugin manager by which we can install Kafka plugin into it, and JMeter can act both as producer and consumer. And this part we will be seeing in the demo, like how we can add a plugin or how JMeter can act as both producer and consumer. And you will get a full control. You can choose a payload format, specify topics, decide partitions, even define how keys are distributed. These things can be done in the JMeter by adding the Kafka plugin and adding Kafka producer or consumer sampler into it. And the best part is scalability. Like using thread groups, JMeter let us simulate hundred or thousands of virtual user, which help us to stress test Kafka under near real world condition. And then in test data parameterization, which is another powerful feature of JMeter, is parameterization. We can connect it to CSV files, databases, or even write Groovy script as I told you earlier, and we can generate dynamic data. And this means our test messages don't look identical like when we make the data dynamic. So what happens is we are every time when we send the request and new data gets created or new message gets delivered to the consumer side, and we would actually see production unique messages, varying value, and realistic patterns. This makes our test much more accurate in predicting how Kafka behaves in real life scenarios. JMeter also provide us monitoring and reporting tools. We have built-in listeners in JMeter, and we can also integrate it with Prometheus or Grafana for graphical representation. Like I told you earlier, we can add plugins for Grafana or Prometheus to into JMeter to see the logs or the results in the form of graphs as per our requirement. And you get only Kafka throughput latency, but also end-to-end test reporting in one place. So this is what you get in monitoring and reporting when you add like integrate either Prometheus or Grafana or even use the built-in listeners of the JMeter. We can also use CI/CD and scalability. JMeter fits well into Jenkins and Taurus pipelines. You can run distributed load test across multiple machines to stress Kafka cluster. Next is key metrics for load testing. So here we will be discussing the key metrics which are required. So when performing load testing on Kafka using JMeter, it is important that we capture the right metrics. These metrics help to validate Kafka ability to handle the expected workload, identify bottlenecks, and ensure overall stability. So we have producer side metrics where messages throughput is like message throughput, how many messages are being produced per second can be recorded, and we publish latency, the time that is taken for producer to successfully send a record to Kafka, batch size and record size, error rate. These all things we can do. Where throughput basically means how much work is done in a given time. And in Kafka, producer send messages per second or consumer receive the message per second. And we can think in this picture like water pipe throughput, like how many liters of water flows through it in 1 second. So this will be basically like we can relate it to how the producer will be sending the messages to the consumer and how we can record it. So this is what in layman language throughput basically means. And latency is basically the time delay between sending a request and receiving a message. So in Kafka, we can have many types of latency, like publish latency, processing latency, commit latency, like ordering a food at a restaurant, like waiting time of the order getting to us is more. So that is what latency means. And in Kafka, we can see these latency in publish, processing, or commit. So next thing is consumer side matrix. So in consumer side matrix, we have consumption throughput, consumer lag, processing latency, commit latency. So in consumer consumption throughput, how many messages are consumed per second are recorded in the JMeter, and we can see this key metric, which can help us to analyze that the data is being reached on the time, or the how much time it is taking. And consumer lag is the difference between the latest offset available in a partition and the last committed offset by the consumer. Processing latency, time taken by the consumer to process a message after receiving it. Commit latency, delay in committing offsets after messages consumption. So these are the consumer side metrics. Broker of Kafka cluster matrix, request latency, produce and fetch, time taken by brokers to respond to produce or consume request, partition, distribution, and leader load, ensuring balanced data distribution across brokers and partitions, disk input, output, and network input output. Kafka is highly dependent on disk and network performance. Monitoring throughput here is the key. In sync replicas count, number of replicas that are in sync, falling falling below the replication factor indicates risk of data loss. Under-replicated partition shows resiliences issues if replicas are lagging behind. System resource metrics on producer, consumers, and brokers, CPU utilization, memory usage, disk utilization, network bandwidth. In end-to-end metrics, we have end-to-end latency, data loss, or message drop rate, or scalability checks. All these key metrics can be captured in the JMeter by testing the Kafka producer and consumers through it. So setting up Kafka. So for setting up Kafka on your desktop, all you need is to go to the official website of Kafka and install the binary file that you need as per your desktop. And after that, we need to extract that files, and we have to do one thing, that is we have to make sure that the extracted file are extracted in a easily accessible path, as whenever we provide some large path or keep in very big folders, so what happens is that accessing it becomes tough job. And for using Kafka on desktop, we also need Zookeeper, which basically comes with the package that is installed. But after installing the Kafka binaries file and extracting it, we need to make some changes to run it on our local. So what changes we will be needing to make is we need to make the change a path in zookeeper.properties file and server.properties file. There are some path that are there which we need to change. If we don't change this as per our desktop, so at that time the zookeeper with these command doesn't run. So after use for starting the zookeeper, we need to just be in the Kafka folder and go to and write this command to start dot property file. And to start the server, we again need to be in the Kafka folder, and we will be using this particular command to start the server. And after this, we can create a topic. Here, on creating the topic, this particular point topic, sorry, this particular topic, and then we have written over your test is the name of the topic, which you can change as per your requirement, like whatever you want to name the test, name the topic. And this is the server where we launch this topic is get created over in this server. And here we are defining the factors and partition. So this is what we can do. We can modify this particular part into whatever we like. And after creating the topic, we can also check the list of topic that we have made, or to confirm that we the topic has been created. You get a message. You after entering this command, you get a message, but to check how many lists you have created or already exist in your um, Kafka. So you can write this command, and to start producer, we use this command, and to start consumer, we have this particular command. After going through all these steps, you will be able to see. Uh, Let me just share. Uh, is my screen visible?
Yes, it
Yes.
is.
Yes.
Yes, yes, yes.
Thank you. So here I have already running this command in CMD. So what I have done is I am in the Kafka folder, and after being in the Kafka folder, as told in the slide, I have wrote this particular command to start Zookeeper. And after entering into Zookeeper, this Zookeeper has to be there in a separate s- uh, command prompt to be running all the times. If this just doesn't run, our Kafka don't won't work here. And along with this, we also need to run the server dot properties to start the server. So we have to be in the folder wherever the Kafka is, and after that we can write this command and come into uh, turning on this server dot properties and creating the server. You will see this kind of response from the server. First of all, you have to start the Zookeeper, then the server, and after that you can do is create a topic. Here, as you can see, I have created a topic named test2, and also before that, I have created other topics, demo test, and test2. So to create any kind of topic you want, you can just go to this command and change the name of the topic as you want. The JMeter test is created. And after this, here I have already started the producer, and this producer is in test2 topic. And similarly, here I have already started the consumer part, and the consumer is already into test2 topic. So now coming to JMeter. Here I have on JMeter, when you start a file, you get a test plan, and after being on the test plan, you can do is add a thread group, which is already over here, and I have renamed it to Kafka Producer with test data. So to test Kafka Producer, what we need to add is a counter. So to add a counter, what we can do is we can click on the thread group and come to the config element, and here we can see counter is there, and also there is this load generator config which is added at the later here. And before moving on to other part, here you can see this particular thing. This is the Java plugin. So I have already installed Kafka, JMeter, and Kafka support and Kafka backend listeners over here. So to install into your JMeter, you can go to available plugin and search for the Kafka. And by clicking on the this particular like this, and click on the apply and changes, you will be able to install the plugins, whatever plugins you want to install. And after installing the plugin, you will be able to see samplers, Kafka consumer sampler, producer sampler, and Java request. Here I have used Java request to send the request to the producer that I have um used in the CMD. And here in the config element also, you will be able to see the Java request default, Kafka consumer config, producer config, and other element, this load generator config also. And by default, when you install JMeter, you don't have this plugin manager. Or here you can, what you can do is you can go on the Google and search for JMeter plugin manager and install it and put it into uh, lib exe folder of the JMeter, and you have to restart your JMeter and you will be able to see this plugin over here. And after adding the counter, what I have done is I have put on the starting value as 0 and increment as 1, and given the variable name as parameter Kafka key, and clicked on this track counter independently for each user so that it track the counter independently. And here in the test plan, what I have done is I'm giving it two virtual users on a ramp up period of 10 seconds with a loop count of 2. So what will happen is two third users will produce the messages in a gap of 10-second period, and they will be producing this two times. And in Java request, this is pretty much very simple. What we do is we select it from here, the producer part, signal Kafka meter, Kafka producer sampler. And here we have provided the broker. So the Kafka is running on localhost 9092. So that is what the broker is. And we have provided it over here. And the test topic is test here. But since in CMD I am at test 2, I'll change it to test 2. And in the parameter Kafka key, the counter variable is what I have added. And in Kafka messages, this load generated config, here I have message to .json file, and the variable name is parameter Kafka message. So this particular file, I have kept it in bin folder so that the JMeter can read this file. So here is the message. This message particularly will be getting in the Kafka producer, and we will be receiving it the consumer end. This is how it looks. And this is pretty much all that we need to change to test the request. So I have already tested it for another topic, and right now I'm just gonna redo it for test 2. Since I have added 10 seconds of ramp up time, so the another request will take 10 seconds, and the request has passed over here. We can see the latency is 0, and the size, and the status code, and also the request message that has been gone there. And here at the end of the consumer, we are receiving the messages that we have sent it via um, JSON file. And what we can do here is we can change this, make it 1, and redo it. And you will be able to see more messages getting over here. So there are more things that we can do with JMeter, but for the sake of simplicity and making this particular part to understand, uh, to deliver it in a simple manner to all of you, I have used this part. Otherwise, we can use Kafka producer config and Kafka consumer config or sampler to produce and consume and load test them. So for load testing, what we can, since the topic was for test management, data management, so from here we can provide it any amount of like file. We can make the changes in the file, and we can add any amount of data we want, and we can also add any amount of virtual users, and we can uh, increase the ramp up time or the loop count. And by using all this, we can see how much time it takes, and by summary report we can see the error rate, the throughput time, and all the other basic matrices that it provides us here. So this is it from my side. If there is any question related to the.
Guys, do we have any questions?
Hi, Renu. Are there any better suited tools than JMeter for Kafka load or integration testing?
Yep, there are many other tools or plugins that we can use. Like there is Pepperbox, which can be used, and other plugins also are there, which we can use to add and simulate as per our requirements.
Okay.
Uh, Renu, one question. So, um, does JMeter has a generic test suite for Kafka, like all the test cases possibly that a Kafka, can be tested on for all the features that it may have for a version or
Uh,
something, or we may have, or do we need a separate plugin or any other
so
external library for that?
we can there is no entire as per my knowledge, whatever I've researched up till now, I don't think there is any particular suite or any plugin which can and completely entirely cover it up. You will be able to do that by either adding a Groovy script. Like from here you can add a sampler, which is bean shell sampler, or add a JSR sampler. Using here, you can provide Groovy script, or you can add, as I told Shreya, there is one more plugin called Pepperbox. So that is there, which provides much more details of the matrices and cover more matrices, but I haven't covered it in here. And other than that, as I showed, that there are sampler for Kafka producer and consumer. So in Kafka producer and consumer, we basically simply just send the message and receive the message. But when we add config element, so here we have all this stuff which we can do. And other than this, there is just a sec. So this is the plugin that we can use. By downloading the jar file, we can add it into the
Okay.
lib/ext, and we will be basically getting, let me just show it to you, what we will be getting. So this is how Pepperbox plain text config will look like. And here we can provide messages, and we can, it works in the similar manner. So this is pretty much what we can do with it. Other than that, if we want to cover up more things, we can always add Groovy script or other any other scripts which are helpful to cover up more things related to Kafka.
Okay. Okay. Thanks, Renu.
Thank you. Thank you.
Anybody else? Do we have any other questions? All right, then we'll take it as a no. So thank you very much, everyone, for attending the session. Thanks, Renu, for the wonderful session.